It's good to be here. Turned out I brought the family over actually for a vacation because I found an airfare for $587 US round trip from the US to Stockholm and back. And seeing the weather out there now, I know why it was so. We did walk around Gamla stan in the sprinkles today, but had a good time. But then I got a hold of some of the local SQL people and then a number of here from the MVPs a long time ago and past summit and things like that, and said, hey, can I speak here? Because I did the same earlier this year in Sydney, Australia. I went there for a vacation, and because I own my own consulting company, I did a presentation there, and then I could write off my portion of the trip as a business expense. So thank you for allowing me to be able to cheat the US government out of about $600. So. If any of you know Pulp Fiction, the movie from Quentin Tarantino, you may get the wolf reference. There was a really big mess in that movie. If you see it, you know what I'm talking about. If you haven't, I'm not going to give it away. But Winston Wolfe was the fellow that was brought in to tell them how to clean up the mess. And that's what I do for the relational engine. Lots of context stuff there. I presume you have some way for me to give you the material so you can download it. I just did a SQL Saturday in Athens last Saturday actually, and that was somewhere around my 90th SQL Saturday as a presenter. I love getting out and spreading the word. Been spending a long time in SQL Server. 6.0 was out. Most people were on 4.2.1 or 6.5 had just come out actually when I started with SQL Server. And all I've done is the relational engine. And I get some comments every now and then on the SQL Saturdays about, oh, that sounds really cocky, you know, when you say you're world class. Even after I show them that, right? Any reasonably smart person that does the same thing for 45,000 man hours, and a lot of that's personal study, you should get pretty good at it. So I changed it to better than average. Love doing tuning type stuff, making stuff go faster than most people believe is possible in SQL Server. But the mentoring, that's why I do a lot of presentations, because I'm pretty good at relaying what can be very complex subject matter sometimes, and I love watching the light bulb turn on. It's one of my favorite things with my 9-year-old daughter, is every day I get so many opportunities to teach her something, and she goes, wow, you know, so I really like doing that. It's also the most important thing I do for my clients is not make something run 1,000 times faster, which is exceedingly simple in most companies, but teaching them how to not do that is what is really a good consultant's going to do. And you're going to learn a lot of things today that you can immediately take home or take to work and help you out. I'm not a BI person. I know some really good ones. I was having dinner with one tonight, actually. But if you need that, I can introduce you to some. So smart people learn from other people's mistakes. You would not believe the mistakes I've seen in SQL Server. But the really good thing, and I say this a lot to clients and during presentations, we're blessed with a really awesome product, right? My 9-year-old daughter could take a SQL Server install disk and go next, 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 just like your admin did when they installed your production SQL Server, and default everything, right? And she can take a third-party install disk for some application and go next, 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 and she has a working database application that hits that database, and it will just serve you up data and do all the stuff you ask it to almost forever. And it's really, really good at that, considering there's some disastrously bad defaults and disastrously bad coding programs and practices that third parties put out there. And sooner or later, if your company is lucky, you reach a certain level of need for scalability, concurrency, response time, throughput, SLA, whatever, and you just got to start doing some things right to get where you need to go. But again, it's an awesome product because you can change one thing, order magnitude, change another thing, order magnitude, stop doing this, order magnitude, right? It's really, we're very, very lucky to have the products that we have. So lots of things that we're going to cover here. I once gave this presentation for the Bank of America's developers. We started out with about 320 people on a WebEx. It was 75 minutes. Over 2.5 hours later, we still had over 200 people there just firing off questions. So we could talk about this until about 3 o'clock next Monday afternoon and just keep going, right? So there's so many things that we could cover, have to cut them out. Reasons why object-oriented just is not database stuff, right? Row by row stuff, right? In any procedural languages, you get some data, you do some stuff with it, you get some more data. Do that in SQL Server, and it's over, right? So inherited responsibilities, that darn consultant 6 years ago built this thing, and now we have to live with it, right? Incorrect sources, right? Google has, every piece of information ever just about is at our fingertips if we know how to look for it. But there's some really bad advice on the web, right? Really bad. So if you do search and you find some blog post or some article, make sure you know two things. One, who wrote it? Do they know what they're talking about or not? Because a lot of people don't. And when was it written, right? Something that Paul Randall said was the best thing since sliced bread 12 years ago is probably not the correct answer for modern hardware and modern versions of SQL Server, right? So always take those things into account. Team collaboration is really hard. If you start with bad design, you're stuck, right? SharePoint, anyone? Navision, Dynamics. Oh, I just picked up a client. They're running on Nav 2009 with like 500 gigabytes of stuff. That's a scary mess. It really is. So it's really nice when a client brings me in before they build the thing, right? Because if you try to fix it 2 years after it's in production, it's really, really, really hard and risky and costly. And if you fix it, what's the 1, 10, 100, 1,000, right? If you fix a mistake in design, it's 1x. If you fix it during development, it's 10 times more costly, risky, expensive, complex. During QA or testing, if you do that, right? It's 100 times more risky, costly, complex than if you do it in design. And 2 years after it's in production, I mean, I've been to a number of clients, and you probably have some stuff, you don't touch it because you're scared, because if you break it, you go out of business, right? So you just have to build tape and rubber band and glue and all that stuff, right? So not testing, right? Most companies that do, I've been to shops that are just ardent agile, scrum, whatever you want to call it, right? And I've been to places that have hundreds of thousands of .NET tests. 0 repeatable database tests. Because up until recently, it was really, really hard, if not impossible, to set up tests that would do the same thing in a database. Because data changes, the structure, the schema, foreign keys, all that stuff gets in the way, right? Now, write down tsqlt.org. Right? If you do that, now you can do database level testing. Awesome framework, free, documented, good examples. So that will allow you to do testing. All right, so lots of other reasons also. And unfortunately, my nice red pointer seems to disappear when I'm on the screen. So we'll have to use the mouse as our pointer. All right, here we go. Pretty much everything else from here on out, it's all samples. So, and like I said, I will get it to the user group. They'll post it up. And whatever we do after this, same thing. All of the samples are either self-contained. They make their own stuff in TempDB, for example, as we're doing here. Or they use public data sets like Northwind, which is still available, or AdventureWorks, which is available on CodePlex. And don't forget, you'll get the chance to play around with these at your leisure. So jump in if you got questions. I may defer them or say, play with this yourself to see what's going on. So here we have a table of colors, right? Pretty simple. And we're going to build a products table, and it has a product description and a color, right? And we're going to put some stuff. Now, up until that point, if you do this in your test, if you test it all, it works fine. The query I'm going to show you. You could have this in production, and it works fine for 6 months. And then those darn users will do whatever you allow them to do. Okay, guarantee it. Sooner or later, somebody's going to do it. So the problem is that guy right there. Okay. I strongly encourage you to design nulls out of your schemas if at all possible. Because if you allow nulls in, you're no longer in Boolean true or false stuff that you learned in 4th grade. You're in true, false, or this nebulous null thingy, right? And how many of you have code sprinkled throughout your systems that say is null, parentheses, my field, comma, tick mark, parentheses, equal to tick mark, or comma 0, not equal to 0, or whatever, right? CPU burn, voiding the use of index seeks, voiding the use of accurate statistics, bad plans, nothing good is happening when you put those in your system, right? Because you allowed nulls in there in the first place. This is an example of the worst possible thing that can happen in data processing. And that is not a corrupt master database. It is not your sand getting hit by a mini black hole and evaporating, right? It is getting the wrong answer with no warning or error. No matter what system or platform or language, big data, small data, no data, wrong answer, no warning or error is the worst possible thing that can happen. So here we go. What are my colors that don't have products associated with them? I have 2 products. They have different colors. I have 4 colors. I get 2 colors back. Until the user does the thing that I allowed them to do, and I didn't test it, and they put a null color in because I don't know what it is. Just put null. Right? What's that? That is the wrong answer. You just gave a patient too much medicine and they died. You pulled the control rods out of the reactor too far and it melted down. The wings fell off of the airplane. You bought too much stock or not enough or whatever. Worst thing that can possibly happen. You allowed nulls in and you didn't test what happens. You didn't build a box around it and bad data resulted. Okay? So, what can we do about that? Often in T-SQL land, there's more than one way to do the same query. Well, we could say not exists with a correlated subquery, and we get our 2 colors. We could do an explicit not ends, or is not null. So we build a box around it by saying discard the null stuff, and we get the right answer. We could use the except keyword, the ANSI thing that came in, I don't know, 2008 or 5, somewhere along there, right? Left outer join, right? So lots of ways. But if you don't know that you have a problem because you designed nulls into your system and you didn't test, that what happens when I put null there? If you allow nulls, you better write some tests that say, I know what's going to happen and it's acceptable, or it isn't acceptable, I'm going to build a box around it and not let it happen. Okay, questions? All right. One down. Functions on index columns and predicates. And what I said about that is null, parentheses, my field, blah, blah, blah. Don't do that. And here we go. Here's some other examples. Customer table. All right. I know I'm going to be searching on the index field a lot, so I proactively build a non-clustered index on it because that's efficient for seeks of small numbers of rows. We like that. Note, thou shalt never, ever write an index statement that doesn't explicitly specify all of the optional things that come with an index statement. Write that down. Okay? That default, what's the worst thing that comes along with that default right there? Kills you. Anybody? The thing that's not written in the with clause here. There's like 8 of them, and one of them kills you. Come on. Who's the, you're the leader of the user group? Fill factor. All right. Fill factor. What's the default? Goose egg. What's that mean? 100. Means chock it full. So when you have a last name, which is spread throughout the alphabet, and so, you know, some might come in with Smith, might come in with Johnson, might come in with Boles. Well, that's throughout the range. So what happens to a full page the first time you put one row in there? Split, Transaction log writes, random reads, memory, latches, locks, right? You gotta specify all of those options. Fill factor is the big one, right? And it should be set intelligently because you know that it's gonna split a lot or it never is going to split. If it's never gonna split, monotonically increasing, never updated, 100% is great, right? Okay, so always specify your create index options for a reason. Here's our table. We'll show a query plan. There is a column with a function wrapped around it. Happens to be a system function, doesn't matter. To my knowledge, there's only one system function that you'll get away with this. Now, one, it's a covered index, so I got an index on it. It should go balance binary tree, find the first L, run till you have no L, and exit the seek, right? That's as efficient as you're going to get. But unfortunately, I get the bad four-letter word. Up there at the top, it says scan, not seek. It didn't go find the first L, run till the no more, and exit. It read every row of every page of my 500 million row table. Putting a shared lock on it, because unlike all of my customers, I didn't put what here? I didn't do that because you're not supposed to, contrary to popular belief. So I put a shared lock on the whole index. No inserts, no updates, no deletes to my main table while I scan this 500 million row index. So not only did your performance go down because you hit that guy, and you flushed useful pages out of the RAM because nothing happens in data unless it's in memory, you also crushed your concurrency for whatever period of time it took to get that into memory and run through it. Okay? All because you wrapped a column around a function. And if you join this to 7 other tables and you look at the statistics you get out of this, they're going to be wrong. It will guesstimate, and it will do probably a bad plan, and performance will tank simply because you got the bad plan out of the optimization process. So what can we do about that? Anybody? How can I refactor that? You can almost always refactor functions out of columns. Make them sargable, search argument, look it up. Right. Anybody? Like, there we go. Like is not a bad 4-letter word. Okay? This is sargable, and if you do DBCC show statistics on a character-based column in SQL Server and look at the 200 steps that comes out, it reads the characters in the columns. And if you have, I don't know, in English, S is a very common first letter of a last name. There's more S's than there are Z's, for example, right? And if you put like S%, it may estimate, say 4% of all the data in your table, or 12%. If you put ZZZY for Zig Zabruski, it's going to estimate 0.02 rows. And you're going to index seek and bookmark lookup and the right efficient plan. So it's really good. When is it bad? The like. That guy. That makes it evil. Right? If you need to do that and there's like words here, you should look at something like Lucene or full text indexing or some other thing that will find words very efficiently in bodies of text. Okay. But this is actually pretty good. And with no function, around a column, there's my good 4-letter word. Seek. Balance binary tree, find the first one, run till you find no more, and exit. You like that? Okay. Now.
Excuse me.
Yep. Question.
Why was with no lock a bad idea?
Why is with no lock a bad idea? Well, most people say, I know I read uncommitted transactions and I'm okay with that. And a lot of times you really are, right? Especially in reporting, or you may know it's a reporting system. It's during the day. There's 0 modifications. Great. Well, you know what? If you have a data warehouse and you're not modifying during the day, what should you do to the entire database? Read only. Then where does all your locking overhead go?
It's gone, right? So if you have a data warehouse that you don't modify, you do all your DML at night, you set it read-only, do your stuff, back it up, update statistics, whatever, and then 6 o'clock in the morning, you're ready to roll, read-only. There's no locking engine stuff. You save all that overhead, right? So that's one thing. But what most people don't know is that if you do with no lock or set transaction isolation level read uncommitted, you will get what's known as an allocation order scan. And think about this being a read head, and the data is coming along, and I'm reading each row as it gets under my read head, and then it's moving along. Well, what can happen in an allocation order scan is I can get to here, I can read that data, it can move along, and this can get updated with a row lock or a page lock or a table lock, because I said no lock. I'm not observing locks. And it can get moved behind me in the heap or the clustered index, and I can read it again. Committed bad data. That's very different from I'm modifying it and I read the old copy of it. Or I read the new copy of it and it's not committed. I don't care. You may not. But to say, here's another case that can happen. Before I get there, I get updated, and guess what? I move ahead of the read head and I don't get read at all. Committed bad data. And when that came out about, gosh, it's probably 8 years ago now when they first found that out, they finally made their way down to the person in the storage engine that wrote that piece of code, and everybody went, no, there's no way it does that. And he went, of course it does. That's what allocation order scan means. Right? So no lock it's more than probably what you thought it was. Right? Committed bad data is a very different thing from they might roll back a transaction and I see what they rolled back. Right?
Do you have that problem in read committed snapshot isolation?
Read committed snapshot isolation, do you have that problem? No, you have other problems. Right? Not the least of which is that guy, because TempDB is getting really beat up now, especially on heavily modified systems. But the snapshot stuff comes with, what happens when you try to update a row that somebody else has updated, conflicts. There's some other things that can come along with that. Let's see here. Customers, primary key. So we have customers and a bunch of sales. Bloop. Uh-oh, compile with errors. Cannot drop because it doesn't exist. All right. So, see this a lot, right? Logically, what does that mean? I want all the stuff in January of 2009. Logically. So write a logical where clause that does that doesn't put columns around a function. Okay? So I have a clustered index on that, so it should be a seek, and it's the 4-letter word again. Right? Wrong 4-letter word. That's reading my 500 million row table, not the index, because this is a fact table. We do index on the date for grouping and range sorts and all that stuff. So we just did that. Oh. Okay. So what can we do? How can we refactor that? Right. Little greater than or equal to thing. Right. And here with the greater than or equal to, we don't even have to bother with the time, right? Which we've always had to fight with, right? And this guy, hopefully, is seek. Binary tree, first value that matches 1/1/2009 or greater until we hit something that's after 1/31/2009 and we exit. It's efficient as you're going to get. Okay. Now, when the date data type came out, 2008 I think it was, totally awesome, right? 3 bytes of storage instead of how many for a date time? 8. That's 5/8 savings in space, and yes, size matters. Every little byte counts, right? You may say, oh, but we have big memory and fast drives and all that. Well, guess what? You have a whole lot more rows than you used to have 5 or 10 years ago too, right? Every byte matters. Microsoft knew this was going to get done so much, they baked it into the optimizer. This is a function around a column that they baked into the optimizer. If you watch this, you can see it use statistics, get accurate statistics, no complicit inversions, none of that stuff. Right? So, Connor Cunningham and his team can do really amazing stuff when it percolates up the priority list. Right? There's a lot of things I'd love for them to put in there. Didn't make the cut. This one they knew was going to happen a lot, so they built a box around it and said, we don't want to take all the calls we're going to get on why this query runs bad. So, all right, questions? Here we go. 2 down. Incorrect subquery. We'll let you play around with this. Just quick look. If you do correlated like this, always, 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 in any Transact-SQL you ever write, use aliases religiously all the time, everywhere. So it used to be S dot, C dot, S dot, C dot. And if you did that and you ran this query, it would fail because that column doesn't exist on C dot. It exists out here. And logically, SQL says, that's fine. And you get the wrong answer with no warning or error. Right? Always use aliases. Right? You can also help the person that has to come debug that 19 table, 43 column join monster 6 months later after you write. You can help yourself because you're not going to remember 6 months later where the heck that 19th column came from. Right? Well, C4 dot will tell you that it, C4, that's, well, unfortunately it's a view that has a view of a view of a view. So you still got to spend 40 minutes getting to where the actual column is, but that's a different story. Data type mismatch and predicates. A lot of times during this session, somebody will pipe up and say, what's the one thing that you, if you could tell everyone to not do, that it would be the best thing that you could tell? And I actually have a lightning talk at PASS Summit this year, and it's like the top 3 T-SQL killers. And number 1 is this. Okay? Number 1, and that is the use of incorrect data types. It's an unbelievable, unbelievable magic bullet. Okay? So let's take a look. The ubiquitous customers table, first name and last name and a customer number. All right, we got a couple of there. Now, I'm going to introduce extreme data value skew to prove a point. But I will tell you that it doesn't take extreme data value skew like we're about to have here to cause problems with statistics and parameter sniffing and all this kind of stuff, right? What's a big Swedish company? Ericsson, is that right? Big company? All right, so say you have customers and one of them is Ericsson and they're 40% of all your data. And all the rest of them are little momsy popsies, 1s and 2s, corner store, or whatever, right? And they have like 10 rows or 1,000 rows, and Ericsson has 40% of all the data. So if you write a query and it comes in and it says where customer ID equals Ericsson, how do you want to access 40% of all the rows in your orders table or whatever? You want to scan the whole thing. Sequential I/O, good as it's going to get, right? And if you go in with the corner store, you want to do an index seek to get the 50 rows out of the 500 million, right? Both of those are the most efficient way. Well, what happens if it parameter sniffs and uses the wrong one, right? Now you do seeks when you should scan and hash, or scan and hash for 5 rows, and you get hit on both sides of the coin, right? So the same thing can happen when you have the wrong data types because of another 4-letter word. And we'll talk about that in just a second. So the extreme data value skew I did was I just put 49,995 rows into a table in a single set-based operation using a table of numbers. If you don't have that in your bag of T-SQL tricks, you must investigate what it can do, right? Delimited string parsing, bam, just like that, right? Set-based operations like this, incredibly efficient, right? Table 1 to n, however big you want to make it. I usually have 3 of varying sizes depending on what the needs are, right? And instead of having a bunch of these, which are all individual log buffer flushes, kill your performance, right? Scripting out 50,000 of these, right? So now we have 50,000 rows in the table. I know I'm going to be searching on last name. What's not out here? Fill factor, page locks, row locks, sorting, tempdb, pad index. All those things should be set for the right reasons. Okay. Statistics.io will show an actual query plan. Anybody see the problem here? 170 reads to get one row. That's probably not optimal. Okay? Execution plan. And what I said about one row out of 50,000, you probably want to index seek and bookmark lookup. That's a clustered index scan. Scan, read the whole table. Right? Also, when you're tuning, take a look at this guy. Right? Always compare actual and estimated. If you've got almost a 5 order magnitude difference between estimated and actual, and I don't care which direction it's going, bad stuff is happening. Why? Why did I get that? Why did it say there's going to be a third of the table or whatever, and there's actually just one? Anybody? Actually, it's on the screen right there. What's the problem? In. That says make it a Unicode string. Well, guess what? A Unicode string isn't a regular old varchar. Right? SQL Server knows that. It's like, I got your back. I'm going to help you out, and I'm going to make that into, I'm going to make the varchar work with the in varchar because they're not the same. And I know you're really busy, so you didn't take the time to look at the stupid schema and see what the field was when you wrote the query. Right? This is one of those mistakes. There is no excuse ever. I don't care how fast you have to slap together a critical fix because your Ericsson client is down. You can look at the schema and see that the definition of the column is a varchar 35, and you make your variable or your string a varchar 35. Never, ever, ever an excuse. Now, you saw the difference there, right? We scanned a table because we didn't use the right data type. This is a 50,000. What if it's a 500 million row table? That's 5 orders of magnitude for simply not looking at the schema and using the right. And it doesn't matter whether it's in Perl or Python or JavaScript or ADO.NET, whatever you're connecting, or SSMS, whatever you're connecting with, a varchar 23 is a varchar 23. It's not an in varchar 55. It's not an integer. It's not a date, right? Always, always, always use the right data type, okay? Now, if we use the right, in this case, no in, we just let it be a regular varchar variable, a character string. 4 IOs, it's a 50,000 row table, right? I mean, you can put mice on a treadmill and compute this thing in a couple of seconds. 42.5 times better on the read performance, 28.5 on the CPU. The cost. 50,000 row table. At 5 orders of magnitude is easy on this stuff. Really, really easy. The convert implicit avoids the use of index seeks. At best, you'll scan your 500 million row index. You saw the statistics problem. So if we join that to 18 other tables and it estimated a third of the table, every one of those 18 other tables is scanned and hashed because it thinks you're reading a big chunk of them. Right? Disastrously bad stuff here. This is the one thing. And that's hard-coded, ad hoc TSQL. Well, guess what? Same thing works in stored procedures. That's my table scan. There's my varchar 35, exactly the right data type. Okay, 4 reads, index seek, bookmark lookup, 1 row, I'm done. Questions? So I had a client. Anybody here deal with ISVs? You buy their product, you look at it, you run it, it's like, man, it's so bad. And you do a little analysis and tuning. They had this one index. The thing would just run so much better. So you call them up and say, look, if you just put this one index on there, click, right? ISVs don't pay attention to you, right? Unless you're Ericsson and you're selling your product to them, because they're then the 800-pound gorilla client of yours. And when they say, put the index on there, guess what you do? Put the index on there, right? So a company got a hold of me and said, we just bought a big new machine to run our medical record system, and it's still really, it's non-functional, right? So I said, and this was about 6 years ago, it was 128 gigabytes of RAM and 32 physical cores, hyper-threaded 60, right? Back then, that was a really big machine, okay? So I said, here's a script, run it for 2 minutes and send me the output. It was a profiler to disk script, just batch level tracing, very simple, tight. You could run it all day, no effect. They sent it back. I looked for it about 45 seconds. I said, there's the problem. So I called them back. I said, I got a magic bullet for you. And I explained it to them. And they said, okay, hold on. Less than 2 minutes later, they had the CEO and the Chief Technology Officer of the ISV on the phone with me. And they said, listen to what this guy says. So I explained it to them, and they're like, oh, that's crazy, no way. I said, no, really, you need to fix this. So 7 days later, they sent back a patch, and the wait states on the server went down by 80%. They didn't need to buy the almost 7 figures of hardware and SAN and stuff that they bought to run this one program on, right? And the one thing they did was in ADO.NET, you can tell it to parameterize the queries, and if you default it, you will get in varchar everything parameters in the SP-execute SQL. So it was scanning everything, it was getting bad plans, no estimates. Convert implicit was chewing the CPU to death, right? One thing they changed, it says just get the right data type. One thing. Could have saved this company a whole lot of money, okay? So, predicate evaluation order. This one is really interesting. Accounts. Yep. So we have what I call, unfortunately, a multivariant table. So we have a reference table that has some numerics and some alphas. And we have business logic that needs to do different things depending on different values. So you will note here that Business Plus and Business Basic both have numeric values. They're castable to integers. The others do not. And I'm going to write a query that says, for the business objects, right? Business rows, excuse me. Filter out anything but those. Cast the value, which we saw, 100, 101, and 5, castable to int. And that must be greater than 20. I should get the 101 row out. That's it. And note, I even, in the where clause, I put my filter of the business rows out first so that the cast would then happen later. Oops. Oops. So let's do this again. That guy. Remember the first row was ABC. So what happened? Very important lesson. The optimizer can do almost anything at once with your query, as long as Boolean and algebraically it gives you the same output or effect. I note that may not be actually the effect you even intended in the first place, but that's irrelevant. So, and if you remember back to your, did I just drop that table? I bet I did. Yep, I think I just dropped my table. Let's repopulate. Bloop. If you remember back to your 4th grade Boolean logic class, and is commutative. That means it doesn't matter what order you do an and in, it will give you the same output, right? And the engine knows that, the optimizer, excuse me, and it says, well, I think it's more efficient to do the cast in this filter first, and then we'll bother with the business thingy. So it blows up when it reads the first row, in this case first. Logically, there's no order in processing, right? Unless we specify it. So I remember that guru guy said you could rewrite, T-SQL stuff. So I'm going to rewrite that T-SQL here. And I'm going to do a derived table. Note it's got parentheses even. And I know there's 6 logical phases to query processing in SQL Server. And I know that the where clause comes before the project, which is the select the output. So I'm going to filter those darn things out. Then I'm going to cast it. And then I'm going to do a filter of the output of the derived table. Sweet. I got it. I got this licked. Oops. So predicates can be pushed up or down the tree in SQL Server query processing. Dang it. So, well, this is a system that we're stuck with because we're not going to redesign that thing, I guarantee you, right? So, we use my favorite 4-letter T-SQL word. If you're not familiar with what that can do for you, I encourage you to get so. It is incredibly powerful and useful. Right? And it's one of the few things in T-SQL land that actually short-circuit most of the time. Right? So what that means is, I'm going to say when the account reference is not like, and this is semi-regular expressionist capabilities of like, pretty cool. Not like character class, negation, not like not a number. Boolean double not is true. So when it's like a number, cast it to an integer. There's no else, so if it isn't, guess what we do? Blow right by it. And that output, end, must be greater than 20. And voila, we get the right answer. Pretty cool. Performance always takes a back seat to the right answer. I'm an efficiency nut. You can ask my wife and daughter. But sometimes you got to draw the line and say, I'm going to get the right answer and buy bigger hardware. Right? Questions? That's cool stuff there. Love the case. Got to find out what case can do. Amazing. Outer joins, placement of predicates. This is another one that will get you the wrong answer with no warning or error. And it can run fine for years, and then it doesn't. Customer table. Take note of Jeff Gordon and Julie Peters. They will not be our friends tonight. Table of orders. Pretty standard stuff. Remember, you get to play around with this at your leisure. Note there's no 4. Julie Peters has no orders. There's 1, 2. Jeff Gordon has 1 order, but it's before January 1, 2009. That's important. Okay? So let's break this guy down. Give me all the orders, or excuse me, all the customers. Give me orders if you got them. What do I get if there aren't any? What comes back? No. That null guy, right? And we join on some key value. And the orders, if they are there, have to be greater than 1/1/2009. And we're doing an aggregate and projecting. And if you show a vice president a null on a report, their head literally explodes. I've seen it happen. So we coalesce it to 0. It's a religious discussion to talk about is null and coalesce, so we're not going there either. And we have a nice report that gives us not for customers. Remember, all customers, orders if you got them. Well, I know that I got the wrong answer because I just wrote the table and I put 4 rows in it. You may not know this when you have 500 million rows in your fact table. And 19 rows out of that many got yanked out. Right? If you didn't write a test, what happens if there aren't any over there? What happens if there are some that don't meet the where clause? That's 2 separate tests that you should have done here. So what happened? Anybody? Where clause. Right? The where clause says, well, you got to have an order date and it's got to be greater than that. Well, guess what? Is null ever greater than or equal to not anything? No. Remember what I talked about initially about nulls? So really what I said was, don't give me orders if you got them. Give me orders. You got to have them. And they got to have a date. So Jeff Gordon got yanked because he had one, but his date didn't match. So I filtered him out. Julie Peters got yanked in the first place because she didn't have any orders at all. And this says, you got to have them. Bad data, no warning, or error. So what do we do about that? Well, this deck and some of the samples were originally written by Playman Ratchev a long, long time ago, like 10 years now, give or take. Not quite that long. So he went through a whole process here of all the permutations you could do for joining customers and orders, starting with a cross join, which is A times B. So there's all customers times all orders. Here's an inner join. Well, I know already I have a problem because I lost Julie Peters. So I know the inner join has to go. Well, let's go back to a left join. Well, I get Jeff Gordon and Julie Peters back. And then I see when I put the where clause in, that's where I lose both the ones that I want. So I know the where clause is the problem. So how do I fix that? Move it. Very good. If I had a t-shirt, you'd be all over it. I have part of a curry sandwich up here if you want. Move the filter over there, right? Or over yonder, to use a southern U.S. colloquialism, right? So now it says, give me customers, all of them. Give me orders if you got them. And while you're over there, check to see if they have this date thingy. And if they do, send them back. If they don't, what do we send back? Send back a null. So Julie Peters comes back, even though she doesn't have any of these, as a null. And Jeff Gordon comes back. He's filtered out, but I send back his row with the null. I don't filter him out after the join. And this, for customers, that's 0 because his got filtered out. That's 0 because she didn't buy anything in the first place. Cool. Well, let's get to the classic parent-child order details scenario to make it a little more complex. So now we have some orders with some order details. So we'll break it down. Give me all customers, orders if you got them. Give me order details also. And that guru guy said to put the predicate in the join clause, so I did that. And I go to 1 row instead of 2 or 4. So I'm even worse off. Problem? So this says you gotta have order details, inner join. Well, guess what? Can you have order details if you don't have the parent? Nope. So this says you gotta have the parent too, because you gotta have the child. So there went all the ones that got filtered out because they don't have orders or they didn't have a 101, right? So the rule is, if you left join to something, thou shalt left join to it throughout that statement. And we get 1, 2, 3, 4. Questions? Subqueries return more than one value. We'll let you play with this. In correlated subqueries such as this, or if you do what I call a select of a select, you put a select up here in the select, right? You get one row or an error. It's good. I like errors. I'd much rather have errors than bad data. So we like, and it's actually a useful error if you look at it. You know this can't return more than one row, and it says that. So if you do these kind of things, you better build a box around this, or 6 months into it, somebody puts another guitar in there, and you get 2, and you start throwing production level errors. And we hate it when our clients call us and tell us that our stuff is broken, when we should have tested that and built a box around it, right? Okay, oops. We'll let you play with that. Select star, don't do it, right? Except in the existence type things, right? Then it's fine. Right? But Playman goes through a very nice example of a view on a table. The view has select star. And what happens when you modify the table that the view is based on? Throws an error. We like errors. Errors are good. Okay? But we don't want it to happen 6 months into production. Right? What can you do to stop that view from blowing up when you alter or drop or add a column to a table?
Refresh it.
With schema binding. Anything you're allowed to put with schema binding on, do so. Write that down. Now you're building a box around the user. In this case, the user is you. Right? Because then if you try to alter the table to drop the column or add the column, the alter will throw an error. And you'll go, don't, got to go change the view. So you have to go check it out of source control. You have all your stuff in source control, right? La, 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 la. Take a business card. That's right. You were laughing first, so I know you don't have that. But there's another reason to do, not do select star. And this one's near and dear to my heart. That's performance. So we're in AdventureWorks. Codeplex, there's like 7 different flavors now, right? One for each major SQL server since a long time ago. And I think I've got this index already created. Note, there's all my things, fill factor, pad index, sort in, tempdb, blah, blah, blah. I think that already exists. Yes, it does. So I have a query, and I did some between stuff, and that's good. And we'll show our plan. Scan 797, clustered index, pretty good estimate, right? I mean, that's really close in data warehousing land, especially, I think we're in, right? It's a transaction history, it's a report thing. So, pretty efficient there, but that's a star. So, I've got 73 columns on my table. There's an XML, there's 3 in varchar maxes, and various sundry other big fat things. I just lifted them all up at that guy, making things go bleh. And I put the blobs into RAM, which flushed really useful hot pages out of RAM. So everything else went slow, other databases and apps, right? And then I bundled it up into TDS packets and sent them over to my web server, which went bleh, if I didn't slow the network down with all the congestion in the first place, right? So it's like a quintuple hit. And then when I got over there, really all the developer wanted was the transaction date and transaction ID. Well, remember that non-clustered index that I built? Because I knew I'd be filtering on the transaction date. Well, that's in there. Well, transaction ID turns out to be ubiquitous identity 11 that everyone puts on every one of their tables, whether they need them or not, right? And oftentimes you shouldn't put an identity on all your tables, okay? Well, guess what? That's a clustered primary key. That's the pointer to the row, and that gets carried on every non-clustered index row anyway, right? So I got that also. And what's this guy called now? It's called a covering index. Because all I need is right there on my non-clustered index. No, there's no touch of the base table. No index, no key lookup, no table scan. Right? And I mean, that's 797 reads or 4 on a, I don't know, 100,000 row table. That's a pretty big win there. And that goes up as the number of rows goes up, right?
Question.
Yes?
What does it say scan count 1?
Scan count 1 here, because I'm just reading this and it's not parallelized. That's what I believe, right? Scan count 1. It's one thread. I think we can see that with F4. Yes. Just one. It's not, you don't see like thread 1, thread 2, thread 0, all that. So it's a single read. It's scan means one hit of the object, I believe, in that case. So. Anybody else?
Doesn't mean table scan in this case.
It absolutely does not, because the plan clearly says index seek as the function. So, okay. Let's make you go away. Ha! Near and dear to my heart. Right? I didn't write the book on this, but I did actually write the chapter. So the MVP Deep Dives 2 book, it has a chapter entitled Death by UDF. It is, in fact, the best chapter in the book. Slightly biased. So when UDFs came out, user-defined functions, in SQL 2005, developers were like, code encapsulation, code reuse, hooray, right? And then they started using them. And consultants like myself went, hooray, cha-ching, cha-ching, right? Because they're not really baked into the engine. And I'll show you, there's like, what did I say in my chapter? It's like playing Russian roulette with 5.92 bullets in the gun. Okay? There's a bunch of ways that they can mess you up. Okay? So here we go. We're going to create function. It takes an order ID. It's a total price. I like appropriately named things. It returns a money. That guru guy said to do the with schema binding. There it is. There's some other good reasons why you want to do that. Paul White has a nice blog post on why you need that for Halloween protection, to avoid the table spool that you'll get for updates if you put this in there. So that's a good freebie there.
Can you repeat that?
Yes, if you use this in an update, a scalar function, you will get a table spool to avoid a Halloween update problem. And Paul White, man, does he really know what's going on in the engine. I mean, he plays around with a debugger on SQL Server for fun, right? Any blog post he writes will expand your knowledge like leaps and bounds, right? So look it up. Paul White, Halloween protection, scalar UDF, and he's really amazing proof of why you need it and what it does and how to not make it happen. So we declare a variable, and what this does is it gets the total price of the orders for the order details for a particular order. Now I can use this in 33 different places without having to rewrite the sum, the aggregate. Code reuse, code encapsulation, hooray. So remember what I said about appropriately named objects. I have a stored procedure that references the UDF in this aggregate here and in the where clause. And note, it's not very restrictive. So if we look at the query plan we get, we'll see that it is some scanny type stuff, but that's okay. Statistics IO on, query plan, run it. It's really fast. Well, it's a pretty fast laptop, even being a small form factor. It has a SSD and 8 gig of RAM and some, I don't know, very recent core goodness in it. And look what it says. 22 reads, 1 scan count of the orders table, and 1 of the customers for 5 reads. 27 reads. Okay, cool. All right, and what I said, it's scans. This is really cool. Look, the merge join. I didn't say merge join. Right? And it's so efficient to do a merge join, and the optimizer knows this. It's all math, right? All just unitless math. It's so efficient to do the merge join, it introduced a sort. That's a temp object operation that's very costly. It's 24% of the whole thing. It did that because it knows it's so efficient to do a merge join, but it has to be in order. So it introduced a sort into the plan to use a merge join. I think that's really cool. Okay, so the plan, nothing really special there other than that neat thing that it did. So let's look at what Profiler has. Oh, wait a minute. So Profiler says 30,609 reads. Management Studio said 27. Okay? Management Studio doesn't tell the truth because the engine doesn't tell it the truth. Okay? Now, I'm going to invoke the Heisenberg uncertainty principle here and say that the act of observing changes what you observe. I actually do have a degree in physics, so I'm okay with doing that, right? But never tune in Profiler and Management Studio at the same time because the act of observing changes what you observe. One place or the other, never both. So let's see what happens. The other thing is, don't tune the first execution of something. Now, in one part, you might be slow because you have to go to that guy, lift it up off a disk if it's not in the buffer pool already. It could be slow because of that. But also, especially for small things, I'm going to run it again. Look at the difference. I went from 196 to 178 on duration, chopped off 31 on the CPU, and almost 300 reads. The first execution includes the compilation and cache of the plan and all that stuff. So if you do that, if you tune the first execution of a small thing, you're going to think, wow, this is really costly. When 50% of it sometimes or more is simply the cost of making a plan and storing it and looking for it and all that stuff. Okay? So another thing,
Question.
don't tune the first. Yes?
So part of the reads are reading statistics, for example?
Reading all kinds of stuff, the first execution. Anything you think happens during the first execution, if it's got a cost, it's probably tracked and it's probably shown in Profiler. And you can see the difference there, right? Now, presumably, if I run this again and again and again, I think it should be pretty static, right? And it's pretty static. Now, so let's look what happens when I turn this off, actual execution plan, turn that off, and now run it. 3331. Look at the CPU and the duration. I cleared it out, unfortunately. It was 190 something, 180 something, 130 something. Look at the numbers. Tracking that actual execution plan and sending it back is expensive, right? If it's a report query that takes 5 minutes to run, you're not going to notice it. But this thing takes milliseconds. And that actual execution plan is a big fat pile of XML, right? So, tune in one place or the other, but not both. Now, I'm also going to do something here that thou shalt never, ever, ever do in a production system. Actually, I'm already doing one. Don't run Profiler in the GUI on your production system. Okay? That's bad. Really short duration, find out what's going on right now. Okay. We're going to go in, and remember I said I have a very efficient, tight tuning profile. And every system I do this on, this is what I do. Text, duration, CPU reads, writes, row count, start time, database ID, SPID. That's all I need, and I can tune the hell out of SQL Server. Pardon my French. Now I'm going to turn this guy on. Statement completed. And guess what? The default tuning profiler for Profiler has. Statement completed. And if you run this on a system with cursors, or scalar UDFs, or multi-statement UDFs, or server-side in hibernate stuff, you're going to get crushed, right? Absolutely crushed. So let's watch what happens. Statement completed. Run. Bloop. Still fast. Holy crap. What's that? Uh-oh. What's this? That's my UDF. Very good. Another t-shirt. Or some more sandwich. Over and over and over and over. And you see this little skinny bar down here? That means there's a metric butt ton of rows up above it. Over and over. Every row, twice. Row by row, cursor under the covers. Sent into the guts because it can't integrate the guts of the scalar UDF into the query. So it has to do the best it can, which is take some data, give me the thing back. Take some more data, give me the thing back. Over and over and over again. So we've got basically a cursor. We have voiding the use of statistics. So we get God knows what for a query plan, right? No seeks, all that stuff just gone. CPU killer, right? So what can we do about that? Well, Paul White, again, has a 2-part blog series on the apply function. Cross apply, outer apply. Really cool. You can write an inline table valued function that encapsulates the same data. There's the with schema binding. An inline table value function is simply a select statement. No variables, no ancillary data access, no nothing. It's just return a select. This can be integrated into the query plan, the estimations, the optimizer. It can be parallelized. Does anybody know that using a UDF voids the use of parallelism in the engine? Yeah, 1 out of however many. Right? So think about your data warehouse now. You have scalar UDFs in play. You hit your 500 million row fact table, and you get 1 thread because you used a scalar UDF. It's probably not going to be good for your performance. Back to our table valued function. So we encapsulate this, and now we cross apply into the function with each order ID. It's a table valued function. It'll do a nested loop and a seek. We put our halving of the same thing, and we don't tune the first execution. Oh, wait a minute, I turned it off. Remember what I said about don't run that statement completed? I'm going to turn it off because we don't want that. Tune the second execution. Crap, it's still bad. In this particular case, it doesn't give us all the benefit that we want, and I'm pretty sure it's because of the halving clause here. A lot of times if you refactor a scalar into this and you cross-apply it or outer-apply it, whatever's appropriate, it will 5 orders of magnitude faster, 3 orders of magnitude more efficient. Okay? But the best way, almost always, is to simply inline the logic of the UDF into the query itself. And I encourage you to look through this to see that hopefully it's logically equivalent to the other thing. Don't tune the first execution, and it's 35 reads. This is Northwind? This is Northwind. This is like 13, 15 years old. You can run this off a floppy disk. Right? And that's orders of magnitude already for the tiniest of tiny. Okay? Just, they got to go. Now, developers always say, but I put it in 33 different places. I don't want to, 6 months later, you have to change a factor from 1.16 to 1.17 because the business logic said we need another factor in there, right? The financial guy said we need to up it a bit. Now you got to go, well, how do I keep track of that, right? The developers, so here's the thing. Select new ID, you get a GUID. You put the GUID in as a comment in your source code where the original UDF was. And you also put that same GUID as a comment in the 33 different places where you inline that into your select, insert, update type queries. You check it all, you test it, you put it in your source control. 6 months later, got to go change it. Go to the original definition, get the GUID, search your source code for the GUID. You have a guaranteed 100% effective impact analysis. You'll find it 33 places. You go change 1.16 to 1.17. You test it. You roll it into QA. They're happy. They roll it to production. Source code's updated, and we're good. Okay? Questions on that? Bad. Multi-statement table-valued functions, just as bad. They got to go. They just have to go. Now, here, real quick, I'm going to show you one of the coolest pieces of function that I've ever seen. And I'm on a new laptop that I may not actually be able to work this with. Let's see. So this is a function that one of only 2 clients I've ever seen, actually ever even heard of, that was CPU bound. Okay? In SQL Server land, it's always I/O, right? Even on SSDs, I have clients that are I/O bound. right? So it's a date formatter, and I'm in a date formatter that makes convert look like child's play, okay? You can send in any one or all of these little parameters in whatever order you want, and it will give you out the date, because they had a bunch of different customers that wanted their dates formatted 6 ways from Sunday. So let's take a look at what we did. Declare, declare, declare. Well, here's lesson 1. If you got this, put it in one declare statement with commas. Each one of these executed separately is CPU, stack, register, pushes, pops, pulls, all that. Okay? One thing. There's some stuff. Sets. You got a bunch of them. You can almost always put them in select, comma, 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 comma. One statement. Sometimes you can't because of the way the nuances work, if you get a row or not, if it's an actual table. Okay? Be careful with that. Oh, we got some date diffs and some more sets that are all separate in cast, converts, and varchar. Varchar 2, seriously, it's more expensive for a varchar 2 than a char 2. Don't, anything less, especially in a table, anything less than 3, maybe 4 should never be a varchar, right? Because you got a dereferencing pointer at the end of how long it is. Okay, so little details there. I digress. Now the cool stuff. Format, replace, 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 replace. Oh, wait, there's more. Replace, replace, replace. It's really cool, though, right? Okay, I do have it on this laptop. So here's just a few examples of what it can do. Thursday, the month, the year. And remember, you can mix and match these into a string this long, right? Very cool. But let's watch this. So cost threshold for parallelism, right? He said earlier, I've got a bunch of other things I can show you after this, and one of them is SQL Server defaults suck. Really hope we can do that. One of them is cost threshold for parallelism. 5 is universally bad. Nobody in this room should have their CTOP set at 5. I'm going to set it to 1 on purpose because I want to do a query that will parallelize. So I'm going to do a cross join, a Cartesian on purpose to get a big query plan. It's like 490,000 rows or something. Okay. Note, I'm just testing performance. The fastest way to test performance is not to spool 490,000 rows back to Management Studio. That's not going to be efficient, right? The fastest way is to put your stuff into variables. Now you're testing purely server performance. Another little tip and trick there. So I'm going to do this. Let me make sure I got profile going. Delete, get ready, and I'll show a query plan, and poof. Pull up this guy, if I can remember how Task Manager works on this thing. CPU. All right. So it's 1/4 of my laptop. This is just 490,000 rows total into a variable.
It's 1 core, one logical process of maxing out, isn't it?
Yep, it's eating 1 core. Why is it 1 core? And what I said about scalar UDFs void the use of parallelism in that part of the query plan. Oh, there it goes. So it took some amount of time here. I have no idea why I can't see the bottom of my thing, but we'll call that 13, 14 seconds. Right? Note what's not here. No little arrows that mean parallelism, or for you, that way. Okay? Single thread, 490,000 rows. And it took that long, because remember it's doing it 1 row at a time, because it can't integrate it into the, and all those set, replace, format thingies. So, well, you know what? This is actually CCYYMMDD. Well, guess what? Convert has been out there forever, and it's tuned to a NATS bottom. And it does CCYYMMDD really nicely. So let's see what happens when I do this. Convert, char 8, fixed, 112, CCYYMMDD. Ready? Blip, that's it, done. Millisecond. Parallelism. Right? UDFs have to go. This was one of the reasons this client was CPU bound. It was so bad, about 4 or 5 clients that they implemented their product on, they had to implement a new SQL Server. The other reason was, and I'll let you chew on this for a while, the lead DBA set the cost threshold for parallelism to 0 on every server. I encourage you to think about what that is, and maybe we can talk about that later. Okay, questions? Bloop. Okay, somewhere in here is there it is. Overuse of cursors, don't use them unless you need to. Sometimes you do, most of the times you don't. One of the times, if you're not on SQL Server 2012 or above, that you should use them is running totals. Cursors are really, really bad in SQL Server compared to other platforms especially. But for running totals, they're almost always way more efficient than other set-based mechanisms prior to 2012 and its new improved windowing functions. Okay? Triggers in multiple rows. This is a cool one. Overuse of cursors. I have an example there for you to play with if you want to. So TempDB triggering is often used for auditing, right? Who cares if we screw up our auditing? Well, only when you get audited and you have to pay big fines because you don't have the audit stuff there. And sometimes in the US, there's things that are actually really important for that. I think I already ran this as a test, so let me go get rid of my tables. Okay, so we have a records table with A, B, and C. Now, we create a trigger, and we make variables that are the same data type. Hooray, the guy said to do that. And I take inserted and join to deleted because it's an update. I want to get the before and the after, vice versa, of that. And I put that in the audit table. Sweet. I'm going to update the first two records and set them to ZZZ. Uh-oh. That is not equal to that. 1 ain't equal to 2. One of those is the update, and the other one is the trigger. Which one's the trigger? 1. Why? Well, it updated my table. Bloop. There's my ZZZ and Z for the first two rows. Okay. My audit table, only one. Note, it happens to be the first one. Does it have to be? No, because there's no order in set-based processing unless you specify it in the outermost action. Okay? Never, ever, ever, ever forget that. Right? Or rely on it. Why did I only get one thingy in my audit table? Because how many things can you put in a variable? 1 max. So if you update 100 rows, you get one of them, whichever one SQL Server cares to drop in the bucket. Where did the other 99 go? They are off in the digital ether, never to be heard from again. And if that's your business logic, you gave the patient too much medicine, you pulled the control rods out too far. Or, like a client that brought me in, they had ported an application over from Oracle, which apparently has an option that can say, do this trigger row at a time for all the things that are affected by the batch. So they brought me in for performance because Oracle is not SQL Server, and if you do things in the same in both of them, one of them is going to be bad. Right? In this case, it was SQL Server. So they brought me in for a performance review, and it was 17 pages long. And at the top of the document, before my name, the company's name, the date, the fact that it was a performance review, I wrote the following. In 72-point, capital, all red, 3 exclamations at both ends, literally to the Chief Technology Officer. And it said, you must change every trigger in your system or you will go out of business. Okay? Think about that. They kept me on to help fix some of the 17 pages of stuff. And every time I interacted with them, I said, what about the triggers? And they said, we only update 1 row at a time. We know we're good. 14 months later, they went out of business. Okay? And I told them it was going to happen. Because what happens when you have to clean up data
and the developer or an admin goes in and says, update this table and set these 129,000 rows to be something. One of them went into the trigger stuff, and the others did not. Okay? So, I'm going to write a, where's my bad trigger? There we go. Drop the bad trigger. And I'm going to write a set-based trigger. Insert audit table, select, join. If it's 0 rows, I'm going to put 0 rows in there. If it's 1, 2, a billion, I'm going to put them all wherever they're supposed to go. That's the smiley face. It's not really funny. If you're modifying data, you should be doing explicit transactioning somewhere. You should be checking for errors and doing something intelligent, whether you pass or fail that check. Every time, without fail. So here we go. Update the second 2 records. 2 and 2. Hooray. Looking good there. 1, 2, 3, 1, 2, 3. Note, they're backwards. Out of order. But there is no order. Right? You can select star from my clustered index table. You're not guaranteed to get the data back in clustered index order. Unless you say order by the clustered index key or keys. Okay? Questions? Always code, and I see this all the time. At clients and on forums, right? Why didn't this trigger work right? First thing, almost always it's written to just handle 1 row at a time. Okay? So back to here. Now, I'm going to call this one. There's a lot of other things I will show you. Let's see here. View, Solution Explorer. We got variable is null, the is null or, the open-ended search. Right? If you have that, actually let's just put this here. All right? So variable is null or and at var2 equals at field 2 or at var2 is null and at var3, right? Devastatingly bad performance. You have to refactor those out, and if you do, you can get 4, 5, or 6 orders of magnitude improvement in your open-ended search queries. Table variable versus temp table. Oh, there's a religious one, right? How many people have you seen forum posts that say if you have less than 100 rows, less than 1,000 rows, use a temp tables or table variable. Table variables are only in memory. It's all poppycock, right? They're both in memory. You can make 2 of them and look in sysobjects and tempdb. They're both there. They both fit in memory until the engine says, I don't have enough room for you in memory, and both of them will flush to disk. Right? The killer, what's the killer about table variables and the reason you should almost never, ever, ever use them? No statistics. Remember what I said about Ericsson, 40% of your data, everybody else, moms and pops, onesie, twosies. I have an example here. 3 rows on AdventureWorks. Table variable gets you the bad plan. Temp table gets you the right plan every time.
I think there are some changes out to the latest versions.
Latest version, you can do a service pack, a cumulative update, I think, and a trace flag, but it still doesn't fix the whole problem. It makes it a little bit better. It doesn't now estimate 1 row all the time for a table variable, right? But you it still will not say that the 1 row in there is Ericsson, therefore you're getting 40% of your rows back. It will not do that, even with the service pack, cumulative update, trace flag in SQL 2014. Still get the wrong plan. Okay. Cursors are bad. Another example, distinct and aggregates, a way to work around that. Distinct counts, how to refactor those queries. Okay, lots of other stuff here. All right. So should we take just a little bit of break? So I want to say other things that I've got here for queries. Let's go back to this, finish up. Bajillions of ways you can go wrong. Contact information. Let's open up this guy. Documents, projects.
personally, I like to do the SQL Server defaults suck. Another option is 2014 new features. Those are the two that I could definitely do. I've got one on, I think I could do one on windowing functions in 2012. Anybody have a unit testing? Unit testing? All right, let's see. Defaults suck. Let's do a quick hands up. Okay, 2014 new features. No. Unit testing. Oh, crap. Flip a coin. So heads, it's unit testing. I don't know your money, so is that heads or tails? Tails. So it's not unit testing. Sorry. Defaults suck. But if you want, I'll give you the unit testing one too, or maybe I'll come present it at Rally. So you can come and see that. So 5-minute break, and then we'll be back. All right, great.